Hello students and welcome to the video. I'm your teacher, Mr. Flynn, and today we're going to be talking about metallic bonds. Okay. I would like you to write down this definition for metallic bonds. Okay, it is the electrostatic attraction between free-moving valence electrons and the positively charged metal cations. So just take a minute, pause the video, and write down that definition. Okay. If you come down here below, this is kind of the main concept. It's not going to get much more difficult than this image. Okay, so we've got these metal cations, okay, and they're positively charged. And then you're going to see there's kind of this dark blue ring, and then there's like a light blue kind of ring in between. It can be kind of difficult to see in the picture, but the dark blue is referring to the core electrons, and then the light blue is these valence electrons. And if you notice, the valence electrons they kind of just blend in between all the different atoms. That's because they're free moving, right here. All right, and we've referred to this as a sea of electrons. It's right here. There's a term. All right, so we have our core electrons, our nucleus, and then we have these valence electrons that are just moving around. And this is what gives metals a lot of their properties. Okay. The reason why it can conduct electricity is because electrons can now move freely through here, right? Because electricity is really just the movement of electrons. Okay. All right. Let's flip the page here. Okay. One of the properties of metals is its ability to be hammered into sheets. We call that malleability. All right. Or it can be hammered, and we can see that when we hammer. Say we took this shape here and then we hammered an edge of it, it would freely move because there's nothing locking it in place. They're just kind of loosely, not really loosely, but they're held together, but the electrons, there's a lot of flexibility that occurs because electrons are not held in place. In the previous video we talked about ionic bonds. When you hit a hammer against the ionic crystal, it's going to shatter. It's because it forms these tight bonds. Okay, metallic bonds are going to be much more flexible. Okay, all right, and then lastly, the melting point and boiling point is affected by the charge. So here we have sodium and magnesium. Okay, magnesium has a higher charge than sodium does, so its ability to pull in its electrons is much greater, and there's more electrons available to be pulled in. So what's happening is the electrons are being pulled together more, and it takes more energy to pull them apart than it is in the sodium. So sodium has a much lower melting point than magnesium does. Okay, so you can find that trend as you work your way across the table. The higher effective nuclear charge, right, you're going to find that the ability for an atom to attract its electrons is greater, and it's going to take more energy to pull them apart, all right, because they're sharing these electrons. Okay. I think that's about it for this video. Thanks again for watching. Until next time.